Hey everyone, welcome to today's episode of the Cyberman show. Today's topic is very interesting, something new, just like the last topic on MCP servers. Today I'm going to talk about vibe coding and associated risks. So we'll talk about the concepts of vibe coding. I'll also share some background on software engineering, how things are developed for people who don't come from development background, then how vibe coding works, risk associated with it, and recommendations, and finally the takeaway. Okay, uh, with that, let's get started. So last week, I was going through an article where I read that this company called Lovable has crossed $100 million ARR in just 8 months. So I was blown away by this fact. It's not an easy feat. 100 million ARR in 8 months is just spectacular. Now then, what I did is I was going through some of these similar companies, but for people who don't know, Lovable is an AI based app development platform, and it is designed to simplify the creation of full stack web apps using like natural language prompts, and it's very popular. As per some of the articles, around 70,000 apps are getting created on this platform every day, and it speeds up the traditional coding process by 20 times for simple ideas or less complicated projects, right? So essentially the theme that I'm seeing across is build with AI. So companies that I work with professionally, friends in my circle, they are all telling me that their enterprises, and this is mostly software companies where I have connections, and some of the companies that are not software is not their primary business, but they are all experimenting with AI, or essentially build with AI is a very common theme. In fact, some of the articles and podcasts, as well as the leadership talks from various keynotes suggest that today at least 25 to 41% code is AI generated, and essentially what that means is these platforms are getting popular. Okay, and you can track this by looking at their ARR. Customers are paying, and this includes not only companies who are adopting these platforms at enterprise wide scale, but also individual developers who are using these tools for their efficiency. So that kind of gave me the idea to look into this, because while new tech always comes, nobody thinks about cybersecurity as a primary use case. It is always there somewhere in the back end, and we'll handle security issues when they happen. Okay, so that's a typical mindset I've heard. Now, with that, let's get into the basics of what this is. So the common term that's used for these kind of platform is called vibe coding. It's essentially an emerging software development practice that uses AI to generate functional code from natural language prompts, and it falls into two categories. So there are two categories of vibe coding tools. One is a simple AI coding tools. So essentially tools like Cursor, Windsurf, Replit, where you give the instructions and they generate the code. And then there are AI prototyping tools like Lovable, Bolt, and in AI coding you have Cursor, Windsurf, or Replit. So in the prototyping side, what happens is you can quickly build the skeleton of the app from simple instructions, and so it reduces the time for developers as well as non-technical users. So you don't have to be a developer to create your app. Okay, that's the advantage of vibe coding. If you have an idea, if you're a teacher, for example, and you want to create an educational platform for your students for a particular topic, you can just start vibe coding and build that platform without understanding code. Okay, so it helps you build apps quickly. Okay, and that's why vibe coding and platforms who support vibe coding are getting popular. Okay, now this includes tools like Lovable. I've not personally worked on Lovable. I've seen how it works because I've worked on multiple such tools just for the sake of playing with them. I've used Cursor, I've used Gemini, Canvas, similar capabilities on chat GPT. Essentially this is AI based coding. I'm putting instructions, it's writing code, and I've played with Python scripts. I've played with some of the scripts on Java's side, as well as something on stock trading. So I use a platform called TradingView, and they provide language in a format or a language called PineScript, and I've developed some custom indicators using that. Okay, and I don't understand PineScript, so using natural language I was able to achieve this. So non-developers like me can write scripts now. So that's very good, very helpful. Okay. Now, but to get into the cybersecurity issues of it, we have to first understand how we came to vibe coding today and where we're going to go. So let's look into some background of software engineering. So traditional software development, it's characterized by human-centric processes. So they rely on explicit logic and structured, predictable development cycle. So the human has full control over the software development cycle. Developers work individually or as teams to write code. Manually, each line is debugged, and it requires extensive technical knowledge of the language and, of course, the problem that you're trying to solve. Okay, so this is how traditional software works. We have trained developers, thousands and millions of developers exist in the world right now. Now, from there, we in last few years with Gen AI catching up, the world started moving towards AI augmented software engineering, and this is where vibe coding falls. And this is where you use an AI code assistant to generate code. Okay, and in such cases, you give a problem or a specific task, and the software like Lovable or Claude or Gemini, they will write that code. In some cases, depending on the tool, full application, and then you can deploy that application. Okay, so this is where you are, as a developer, you're taking assistance from the AI programmer, your AI co-pilot, to build code. Okay, now this is the current state which is very popular. Now where we are going is the AI native software engineering, which is essentially about more involved usage of AI based tools, more towards autonomy and or semi autonomy for tasks across the software development lifecycle. So AI can handle some of the tasks completely on their own, and for others it would need little human guidance. And this is where humans and AI will work together, with humans guiding the overall process, essentially working as an orchestrators of all the tasks, and AI programs, call them agents, understand what human wants to achieve, and they make it happen by translating the human intent into action. And typically it will be a multi-agent system, including things like specification agents, architecture agents, coding agent, testing agent, deployment agent, so on and so forth, right? So this is the future. So we started from manual coding, writing every line of piece, to AI augmented, which is what we are doing today. And now slowly we are going towards the AI native software engineering. Okay? This is where I expect a lot of money going into. I'm already seeing some companies who have automated AI-based testing, and some other phases will also get to have AI, and then an orchestrator system can be created that will put all these two systems together and ensure that applications are developed in a much faster way with full software development lifecycle concepts. Okay, so this is some background on software engineering. Now, so going back to vibe coding, right? The input that the vibe coding tool takes is human language, and let's say I give an instruction, create a code that fetches the prices for my favorite product from top 10 websites in the world. Okay, and I give it a list of websites. Okay, so the coding agent or the vibe coding platform, it's going to create that code, fetch all the APIs, and then will generate user interface, or it will suggest, depending on what kind of prompt you have given, it might suggest to give you a user interface also. And then once the output comes back, user can redefine or look into what came out. If you don't like something, it can keep giving inputs till the final outcome is liked by the user. Okay. Now the thing with vibe coding is that the code is accepted without fully understanding how the code got implemented. Now that's where the issue lies. Okay. So again, reiterating, user gives an input in natural language, system creates on the code is given back, and that is accepted by user. If it works for him, who cares what's happening in the backend, right? And that's the thing that leads to all the risks that are there. Let's look at those risks. So what I did is, while I was researching this, I found out two amazing reports, one from Veracode. Let's start with there. So this is a report called 2025 Gen AI Code Security Report. It was published by Veracode. They are into AppSec business. Again, no association. I just found them amazingly interested from content perspective on this topic. So they did a study, and the goal of this study was to quantify the security properties of AI generated code across a range of languages and model. And the central question that they were trying to answer is that what happens in the absence of security specific guidance? Essentially, are the LLMs generating secure code or not? Okay, so their methodology involved a complete test set that had around 80 coding tasks. They use over 100 LLMs covering a wide range of model vendors and target applications. Example, general purpose software or creating a code for a specific task. Okay, and the goal was to assess the security properties of each model, how the security trend has evolved as the model size has changed, and have models been getting better at security over time. Okay, and they created these sets that had tasks to identify security vulnerabilities. So essentially what they did is, if you give a task to the AI copilot or AI code generating platform, the same task can be written in a secure way or on the unsecure way. So the purpose of this test was to find out if by default, without any specific instructions, the code that gets generated is secure implementation or an insecure implementation. Okay, and once the output came, Veracode was testing the code and the model with their SAST products, and SAS stands for Static Application Security Testing product, and this test focused on 4 common weakness enumerations categories. This includes SQL injection, cross-site scripting, log injection, and cryptographic algorithm implementation. And they tested it across 4 programming languages: Java, JavaScript, Python, and C#, and 5 different coding tasks instances for each combination of target, CWE, and programming languages were given. Okay, so for those who don't know about CWE or common weakness enumeration is a standard classification system of common security weakness and vulnerability. Essentially, it's a common language for describing software flaws. Okay, and each category of software weakness is identified by a unique number. So example, CWE79, it stands for CSS, cross-site scripting. CWE259 stands for use of hard-coded password. Okay, so if the software finds or a person finds this issue, they will categorize this issue in this particular category of weakness. Okay, so with that, let's go into the results. So this particular report highlighted something very strange. I was expecting it though, in full honesty. Okay, so what the report says is that across all models and all tasks, only 55% of generation tasks results in insecure code. In other words, 45% of these tasks of model introduces no security flaw into the code. Okay, that's number 1. Number 2, larger models do not perform significantly better than smaller models. And number 3, security performance has been largely unchanged over time, even as models get better at generating syntactically correct code. So while models are getting faster, better performance-wise, security-wise, there's no change in the trend. And this caught my eye because what I was expecting is that as large companies are releasing their code generation models, they would also focus on security. But 45% is a big number. Now, what this report also highlighted is that for SQL injection and cryptographic algos, models are performing relatively better over time, but for CSS and log injection, models generally perform very poorly and appear to be getting worse. And it could be because the CSS and log injection are complicated problem to solve compared to SQL injection and cryptographic algos. And remember, they did not even go into all categories of CWE. They only went into 4 categories of CWE. So that was interesting. And essentially what it stated is that there is an issue with the code. Okay, the second report that I read related to this topic is something called as Backbench. So Backbench is a evaluation benchmark consisting of 392 tasks for testing the capabilities of LLMs to generate correct and secure backends, and it's jointly published by or created by ETH Zurich, Logicstar AI, and UC Berkeley. So I found this paper on the archive site, and their findings are similar. That only 35% of the generated backend codes were both correct and secure, and on an average, security exploits were successfully executed on more than half of the functional correct programs generated by each LLM. So what these two studies are telling us, while we are generating these codes, they're still vulnerable. Okay, some of them could have very basic vulnerabilities also, because whether you take the number 35% or 45%, it's a large chunk of number. So if we are making these companies or any person who doesn't have the development background capable to generate these applications, it's gonna leave a lot of attack surface open, which means cyber criminals, hackers, whatever you want to call them, they will be able to get into these apps, bring them down, or worse, extort. Okay, so that's a major issue. Okay, so so these are the problems. What are the recommendations? And that's where I went and did some research, found an amazing paper by Cloud Security Alliance. And what this paper starts, it's some of the best practices of application security, DevSecOps, secure SDLC, along with some things that are specific to vibe coding. So let's look into all those things high level. So let's start with things like by default treating AI generated code as drafts and not pushing them into production, and human reviews are paramount. So you are using the code, but don't push it into the production unless it's validated by a human. So mandatory code reviews for all AI generated code has to be the default principle. Okay. Now I know large enterprises will comply with it, but nothing is preventing a small company or an individual developer, a person who's working on his own, to ignore all this and just push the code, because they are eager to test this out in public and make some money off it. Okay. The second recommendation that came is, of course, including the security fundamentals, which is avoiding hard-coded sensitive data, securing API endpoints, validating input, configuring cross-origins resource sharing properly, using HTTPS, doing peer reviews, involving AppSec best practices, including things from OWASP, secure coding practices like least privilege, data encryption, CI/CD security scanning, uses SaaS of DAS tools that are popular in DevOps, securing the code repo, security of data store or database, and then specific threats to AI in case your AI application or application has AI capabilities. So looking at OWASP and agent LLM top 10, and then of course the security of the compute hosting this application. Okay. Also, the best practices have to be followed from any of the tools that are there for code generation. Okay. Now, the most important thing in this is ensuring that secure vibe coding is done by using prompts containing security specification. What does that mean? An example could be, instead of just writing create an endpoint, you can write create an endpoint that authenticates using an API key stored securely in an environment variable. Another example, instead of just writing create a function for specific task, you write create a function for this task that validates the user input, so ensure it matches a specific format or range before processing it. So you're doing the input validation checks. Okay. Also, so depending on your background, and now it's very important to understand how security is taken care in the vibe coding or the AppSec side. It's important that you imbibe by default all those principles into your prompts. Okay. So secure vibe coding is a shared responsibility. Now, so those are the risks that I mentioned. So code is insecure. It can be hacked easily using automated tools or some of the exploits that are there. And then there are recommendations and best practices, including traditional ones as well as specific to vibe coding. Now, what are the key takeaways? One, we will have new skills. Okay. From all the literature that I've read, one is one thing that's going to happen is AI PMs, AI product managers will be the new job. These will be people will be responsible to build AI features or use AI to focus on high leverage tasks as well as prototype with AI. Okay, so you'll be asked to create quick prototypes without asking the development team to go full on. AI PMs have to be smart enough to use a vibe coding platform to create the application that the companies want to test. The second thing that I found is the AI AppSec will be a critical skill set for cybersecurity folks. Of course, even for developers also. So if you understand about basics of cybersecurity, basics of development, start learning on the security side, especially the OAPS top 10, at least the basic security check hygiene that is associated with the application development has to be learned by every developer is what I recommend. And of course, lastly, the new skill will be to build secure prompts beyond the AppSec and code recommendations of these platforms. So these are the key takeaways for me. So what I'm going to do personally is I'm going to although I'm testing, but I will start looking into learning how do I put up a secure prompt when I'm using a vibe code tool. Okay, and of course, if I can create prototypes with the tools that I have access to. With that, I'm very thankful to all the sources. This includes Cloud Security Alliance document called Secure Vibe Coding Guide, the Backbench paper from archive.org, and as well as Veracode for their recent report. Thank you. I hope you found this useful. Keep sharing, keep liking, and I'll see you guys next time.